All right, this is section 4.6, related rates, page 1. The first 2 pages here, we are going to work on the mechanics of related rates, and the last 8 pages will be the application of those related rates, or the word problems. And related rates are when we talk about how fast one particular quantity is changing in relation to how fast a second quantity is changing. So for the first example, we'll assume that x and y are functions of a third variable t. The first thing that we want to do here is to multiply by y so that we get rid of the possibility of having a quotient rule here. Then we're going to differentiate with respect to time, with respect to t. When we do a derivative of x with respect to t, that derivative is dx dt. That's the derivative of x with respect to t. On the right-hand side, this constant multiple of 10 comes down, and the derivative of y with respect to t is dy dt. Then substituting in the information that we know, dx dt is -5. And then solving for dy dt. And dy dt is -1/2. That's it. Look at this next one. And we assume that x and y are functions of a third variable t again. So there's some x equals blah, blah, blah t. Y equals blah, blah, blah t. But then we have this relationship. If 2 sine x plus 4 cosine y is equal to 3, and dy dt is 3, find dx dt at that particular point. And we'll start by doing a derivative with respect to t. This constant multiple 2 comes down. The derivative of sine x is cosine x times the derivative of the x. But remember, x is some function of t. So we need that derivative dx dt. There's kind of a chain rule going on here, where this x is some hidden function of t, plus then the derivative of this 4 cosine y. The constant multiple 4 comes down. The derivative of cosine y is negative sine y. Notice I put a times here so that I don't think later on that that's 4 minus sine y. So that's 4 times negative sine y times the derivative of the y, dy dt equals, and then the derivative of this constant 3 is 0. Cleaning this up a bit, we have 2 cosine x dx dt minus 4 sine y dy dt is equal to 0. Let's see, now we don't plug in all of the information all at once. The only thing we plug in is this given rate. And you were given this rate right here, dy dt is 3, so we'll plug that much in. 2 cosine x dx dt minus 4 sine y times 3 is equal to 0. Again, cleaning this up. And now solving for dx dt. Dx dt will be 12 sine y divided by 2 cosine x, which simplifies to be 6 sine y over cosine x. And that is the derivative dx dt. But we want dx dt at that particular point. Now substitute in that specific point, and we'll have dx dt at pi over 6 comma pi over 3. And when we sub in here, the pi over 6 is x and the pi over 3 is y. So we have 6 sine pi over 3 divided by cosine pi over 3 remembering your unit circle values, the sine of pi over 3 is square root 3 over 2. Uh-oh. Oh, that was right for sine pi over 3, but this shouldn't be cosine of pi over 3 down here. This should have been cosine of pi over 6. It's going too fast. Sorry about that. Cosine x, so pi over 6. And the cosine of pi over 6 is square root 3 over 2. Very nicely, these square root 3 over 2's divide out, and we are left with 6. And we have that dx dt at pi over 6 comma pi over 3 is equal to 6. Thank you.